So is the countdown. So today, what we're doing is basically going to be a review for most of you. You guys have seen this stuff before. We're going to be talking about real numbers and their properties. And ultimately, what we're talking about is how number systems are organized, right? I'm going to put me. I forgot to do that part. Usually I'll be in the video. Today you're just going to hear my voice. Normally there's like a little thing of me in the corner, but I have to go and like reset how everything's done on Screencastify to do that. So it's just going to have to, you're just going to miss it this time. You're just going to have to look at me. So we're talking about organizing numbers and number systems. And I like to lead off with this every year because I think it's good information for you guys to have and to understand that the numbers that we deal with are part of a larger system. And you guys, like when you were in elementary school, like you started counting, right? And you started, what did you start with when you first started counting? Probably fingers, right? Like 1, 2, 3, 4, 5. And that is part of the real number system, but the whole number system gets really big, right? And for right now, we are just talking about what we call the real numbers. The real numbers consist of two groups of numbers, right? You have the rational numbers, and yeah, you guessed it, the irrational numbers, right? Now, the rational numbers have all of these subcategories. And the one that you're most familiar with would probably be the natural numbers, right? The natural numbers, we'll do this. Rational has the natural numbers. It has me not being able to spell. Natural. See what I mean by this like thing is super weird? Now I've got this funky arrow thing. What the heck, man? I don't know what I did to make that happen. The natural numbers. The natural numbers are your counting numbers, right? They start with 1 and they go 2, 3, forever and ever to infinity, right? But they're all whole numbers and they start with the number 1, right? It is the smallest set in the real numbers, right? It's still an infinite set. It still goes on forever and ever, but it excludes parts, right? So it is the smallest set. The next set you're going to have is the whole numbers. Now the whole numbers is just like the natural numbers, but it just has one more number in it. Can anyone guess what that number might be? Yeah, 0, right? The whole numbers, just like the natural numbers, only instead of starting with the number 1, they start off with, what the heck? This new whiteboard app's going to be like my downfall. 1, 2, 3. And again, it's still an infinite set. It still goes on forever and ever and ever, right? We can always just add one more number to it. But the difference is this one starts with 0, right? So notice if you look at the natural numbers, they all fit into the whole numbers, right? Every natural number is also a whole number, right? So if I were going to like put them in a thing, I'd say, okay, well, I've got the natural numbers here, right? Which is n. And I've got The whole numbers, which is all of the natural numbers plus 0, right? Our next thing that we've got is the integers. Now, notice I used an N for the natural numbers and a W for the whole numbers. What do you think I would use for the integers? Here's a little hint. You're going to be wrong. Right? 'Cause you would think it would be an I, but it is not. For the integers, we use the letter Z. Mostly because I is already taken, because we use I for the irrational numbers. So integers, well, it contains all of the natural numbers and all of the whole numbers, but it also has all of those numbers in the negative form, right? So we just massively increased the size of this infinity, right? Because we can go in either direction, right? I can go -2, -1, 0, 1, 2, and I can go on to infinity, right? Forever and ever and ever in either direction now. But if you notice, all of those natural numbers and all of those whole numbers still fit into that category of integers, right? 1, 2, 3 is still in there. 0, 1, 2, 3 is still in there, right? So if you looked at it, if we went to our circle right here, we could go, okay, well, now we've got this bigger circle that has these two other circles, right? It has the natural numbers, it has the whole numbers, and they're all contained inside the integers. Make some sense? Maybe? Next, the next category in the rational numbers is, in the rational numbers are the rational numbers themselves, what we call the Q, right? Why do we use Q for rational numbers? That's like $1 million question. If anyone could tell me why we use Q for the rational numbers, I'm going to give you $1 million imaginary dollars. But let's start with what they are. We can use the rational numbers are any numbers that can be written in the form of a fraction, right? A non-repeating fraction. So if I have -27, well, that can be written as -27 over 1. So that can legitimately be written as a fraction, right? So every whole number is a fraction, right? Because we can write it over 1. It could also be -3/2, or -1, or -1/4, right? All those things work. Then we also have 0, and we can have +1/4. +3/2, 7, and this is going to go on forever in either direction. R is already taken. Well, there is that. That's not a bad a guess. But why would we pick Q? I can't tell you why we pick Z for integers. I have no idea, but there's an actual really good reason for why we pick Q. And that is that it stands for quotient. And quotient is what you get from division problems, right? It's like the answer you get from any division problem is the quotient, and every fraction is just a division problem, right? That line in a fraction actually means divided by. Like if you ever look at the division symbol, when you look at the division symbol, you have the line with the 2 dots over it. It's just an empty fraction, right? These dots represent whatever your fraction is. So if it was 3 over 2, that's like saying 3 divided by 2. And so the reason we use Q is because it stands for the quotient, which is what we get when we divide. So all of those numbers fit into this circle right here, right? So Q is the biggest set, and it contains all these other sets, right? So we have our quotient and our rational numbers, and it contains our integers, and that contains our whole numbers, and that contains our natural numbers. Have you ever seen those old like Russian nesting dolls where you have like the little one and then you got the bigger one, like each one fits inside of it, and they're all the same, but they get smaller and smaller? Have you guys ever seen those? Think of like measuring cups, right? When you stack your measuring cups, have you ever seen how each smaller one fits inside the bigger one, right? Like all those amounts are contained in the bigger one, but you just got smaller ones that make it up. So I want you to think about that in terms of real numbers. We've got all of these subgroups of the rational numbers, but we've left out, boom, these suckers right here, the irrational numbers, right? Well, the irrational numbers don't fit within this group, but they fit in this box that we would call the real numbers, right? And the reason I said we can't use R for rational numbers is because we use it for real numbers, which is that big box that all of these systems, all of these sets of numbers are contained in. Now, the irrational numbers are contained in that same box. They're just not in this bit of it, right? They would be like over here, right? And they consist of things like pi, right? Never ending, right? Pi is like 3.14152. I don't know. I can hear Miss Walters over there like yelling numbers at me. But it goes on forever and ever. It's never ending. Other things that might be in the irrational numbers, square root of 2, right? Square root of 5. We don't have like real number solutions for these. They go on. We have another one called E that we'll get into later, but all of these things fit in the rational numbers, right? They go on forever and ever. There's no distinct point. We know kind of where they would fall on a number line, but we can never get to the exact point because they don't have an exact point, right? They go on forever and ever. Like I can tell you that I know that pi is between 3 and 4 on a number line, and we know it's a little closer to 3 than it is to 4, but I'm never going to find that exact spot because it doesn't have one. Make some sense? All right. So as far as organizing numbers, that's all we really have is in terms of defining it. So let's look at a couple of actual real numbers, yeah, and see where they would go in terms of this system that we put up, right? So if I have, see, it's doing that thingy again. If I have negative 10, I don't know how to make it not do that. All right, let's try that again. Negative 10. If we looked at negative 10, what is the smallest group here that negative 10 would belong to? So we've got the natural numbers, and if you look at the natural numbers, there's no negatives in there, right? So it can't be part of the natural numbers. If we look at the whole numbers, again, the whole numbers start at 0. There aren't any negatives in it, right? So it's not going to be part of the natural numbers, and it's not going to be part of the whole numbers. But if we look at the integers, that's where we start with the negatives. And it is a negative whole number, right? It's a 10. It's not some weird fraction, right? It's not like 10 over 3 or anything like that. It's just negative 10. So the smallest group it's going to belong to is the integers. What the heck is going on? And so I don't even know what this thing is doing. Look at that. I can do weird stuff, but not right. I hate this new app. I have no idea how to stop it from doing that. So let's see if it'll work. So we could say that it falls under Z, right? But it would also fall under everything over that because it's part of the integers. It is also part of the rational numbers, right? So it would also be in Q, and it would also be a real number. So anytime you find the smallest set, it's going to be part of that set, then everything bigger than that it plugs into. Does that make some sense? All right, I got one or two nods, so I'm going to go with that and assume that all of you understand, right? The irrational numbers, they're just one group, right? They would be irrational and they would be real, right? Because everything we're dealing with right now falls under the rational numbers or under the real numbers. This whole box actually fits in another box, right? You've got this number system and this number system, but we're not going to get into this until a little later in the year. But they all fall under what we call the complex number system, right? And that's going to be a C, but you don't have to know that right now. I just want you to understand that the real numbers are huge. They're infinite. They go on forever and ever, but they are all part of the real number system. I'm looking at the time here and hoping I have enough time to get through the next part. So I was going to continue this a little further and talk about properties of real numbers, but there's no way I'm going to be able to get through it in that time. So you get to not worry about the Delta Math assignment yet because it's for the second part. And I'm going to make you guys up a question under in the category of organizing real numbers. And we're going to talk about this a little bit more, and then you guys will do a question and I'll just leave you at the question. So your only homework assignment won't come till later this week. All right, on the second day. And it's just a Delta Math assignment. Those of you who want to start it early, you can, because anytime you get something wrong, it'll give you like a little video. So we know that 10, right, falls under the integers and the rational numbers and the real numbers. What would 1 and 7? What would 1 and 7/9 fall under? Clearly not a whole number, right? So we can't start with that. It's not going to be a natural number. It's not going to be a whole number. It's not a whole number, either positive or negative, so it wouldn't be an integer either, right? Because we have to have whole numbers in our integers. So it's just going to fall under the category of rational numbers and real numbers. Does that make some sense? Right? Once we know that it's a rational number, all it can be is rational and real, right? If rational is the smallest. Yes, Linda. What about all right. What if I had 24/8? I like this problem because what is 24/8? What is 24 divided by 8? 3, yeah. So we've got ourselves a whole number. Good job, Dylan. So this becomes a whole number, right? We've got 3, so it's going to fall under the natural, the whole, the integers, rational, and real. It would be in every category, right? We would have N, W, Z, Q, and R. It qualifies as all of them because if anything is a natural number, it's a natural number in every other category that sits in. So your question, should I be able to actually write it, is, see if we could do it as a poll, is, of course, I took my keyboard over here to have it out of my way. Is I'm like, let's do one that's not too hard. Let's do, I'm going to give you the letters, but I'll keep them posted. How's that? Sorry, I know it's taking me a long time. All right, here we go. Did you guys get the poll? Seeing all the votes coming in, hopefully. Sorry, the Q is the rational, Z is integer. If you look at the screen that I put up, you can see them. W is whole, N is natural, R is real. Just waiting for some more votes to come in. So far, I've got 9 and through 12 of you. All right, so you guys ready to see the results? Looks like I got enough of you, 10, 16, almost everybody is in. So the results show that most of you chose QR, right? Which was the actual solution, right? 3.5 is a fraction, it's 3.5. So it's gonna have to be under the QR, right? The smallest thing it could be is a rational number, right? It's a fraction, it's not a whole number. Everything else is a whole number. So we have to start at Q. So the only two things it could be would be Q and R. Does that make some sense? So you're not going to really have any assignments with this, I just wanted you to understand how numbers work. And that was really the goal, the effort of this video here was, or this lesson. It's not really a video for you guys yet.